Hi students, welcome in chemistry classes. I am Priyanka Jain and today's lecture is about the hydroboration reaction. As we are studying for csirnet, GAT, IIT Jain, so we should know the stereochemistry behind it. Okay, so we will study this reaction with stereochemistry. Okay, all the important type of reaction I will do here so that you can understand whole the concept. Okay, so let us start the video. First of all, understand what is hydroboration reaction. Hydroboration means the addition of borane across the pi bond. The pi bond may be either a double bond or it may be a triple bond. Okay. So what happens firstly? This will attack at this pi bond so that a cyclic transition state is formed like this. On one side BH2 is added, on the other side hydrogen is added. Okay, a cyclic transition state like this is formed. Okay, then we will get in this manner a product. Okay, but this is not the final product. Actually this reaction is accompanied by treating it with H2O2 in the presence of OH minus. So that what happens, this BH2 group is now changed by OH group. Okay, and this happens with the retention of configuration. I am firstly telling you what is the general reaction, then we will see the stereochemistry. Okay, so this BH2 is now changed by OH. Okay, so we are getting a alcohol like this. Okay, so actually this is the hydration reaction. Hydration of alkene means the addition of H2O along the double bond. You can see this H and OH both are added on the two sides of the double bond, so we are adding the water. Okay, so we can call this reaction a type of the hydration reaction. Okay, and what is the characteristics of this reaction? See here, this is stereospecific reaction, one thing. Okay, and we are getting a syn addition product, second thing. And the addition is happening according to anti-Markovnikov's rule. It means the reaction is not following the Markovnikov's rule. Okay, so these are the three important things that we should know about this reaction. So first of all, understand what is meaning here of stereospecific reaction. Means to say we are getting only one type of products out of the two products. Okay, and actually what is happening, the both hydrogen and OH or hydrogen and BH2 are added on the same side of the double bond. It means either they are added on the above the plane or they are added below the plane. It means both are adding at the same side, so we are getting a syn product. Okay, and thirdly, it is anti-Markovnikov's addition. It means this hydrogen is added at the more alkylated site. In general hydration reaction, whenever you have seen the general hydration reaction, what you have seen, the hydrogen is added at the less alkylated site. Why? Because in that way we are getting a stable carbocation. Okay, you have seen the reaction when we do the reaction with H plus and H2O. In that reaction you have seen that the addition of H2O happens according to Markovnikov's rule. This is according to Markovnikov's rule, and you are adding the hydrogen at the less alkylated side. Okay, but in this reaction you are adding the hydrogen on the more alkylated side. Okay, why this is happening? We have seen that we are adding BH3. Okay, we are adding BH3 along this double bond. Okay, or in general way we take the organoborane compounds. Actually this BH3 is highly active and we take the organoborane compounds like this R2BH, or we can call it C6H11 whole twice BH. Any alkyl group can be added to this boron. Okay, so that we are getting organoborane compounds. Now these are added on this. Okay, suppose this alkene is unsymmetrical. Okay, suppose we are taking like this CS3 CS3 H H. Okay, we can take it. Okay, so what will happen, this will be above the plane and this will be below the plane. Okay, so when you are adding this R2BH, okay, we are adding this. Then this R2B group, okay, this will divide into two parts. One part is R2B and one part is hydrogen. So where the hydrogen will be added? See here, this R2B group is very large. Okay, so this will prefer on the less hindered side. It means it will go on this side. Okay, this side is sterically hindered. So it is not preferred that this R2B group will go on this side. This will go at this side and this hydrogen will go at this side. So as a result, what you are getting? You are getting a product like this. Here you will add hydrogen. Here you will add Br2 group. Okay. Now you are doing its hydrolysis in the alkaline medium so that you are getting C, C, CH3, CH3, H, H. Okay. And here you will get OH and here you will get H. Now you can see that both OH and H are added at the same site. It means either both are added at the above the plane or both are added below the plane. Okay, so this is a type of syn addition. Okay, and you are getting a stereo specific product. Okay, and you can also see here that the hydrogen is added on this more alkylated side. So it is opposite to Markovnikov's rule. Okay, all the things are clear. Now we will understand whole the concept with the help of examples that are given in your reference book. Okay, see here. Suppose we are taking a cyclic product, cyclic alkene. Okay, then this is the methyl group. Okay, so suppose methyl group is above the plane. Okay, this is above the plane. So what will happen? This BH2 will go on this side. Okay, and hydrogen will move on this side. We are treating it with BH3. Okay, now you are treating it with H2O2 in presence of OH minus. Then this is CS3. Okay, and this is hydrogen and this BH2 will change by OH. Okay, so that you are getting a syn product like this. Now see one more example. Suppose we are treating it with BH3 and firstly we are treating it with BH3. Okay, and secondly we are treating it with H2O2 in presence of OH minus. Okay, so what will happen? See here. Firstly we are treating it with BH3 so that see here BH2 will move on this side. Okay, BH2 will move on this side and hydrogen will come here. Okay, so we are getting firstly we are getting Ar Me C C H Me and then here BH2 and here hydrogen. Okay, and then we are treating it with H2O2 and OH minus so that here this will change by OH minus. Okay, this we can change now with OH so that we are getting this type of product. Now we can write it like this. Ar, here will be hydrogen, okay, Me, and this is hydrogen, this is methyl group, and this OH. OH is always syn to this. It means we are getting here a trio type of alcohol. Okay. This example I have taken from the Carothers. Okay. Several other examples are also given in the Carothers. Okay, so you can also try yourself. This is our alkyl group. Okay, and this is added from here to BH. Okay, so two such type of groups are added. This is two. Okay, so we can write it like this. We can write it. This is R2 group. Okay, this is R group. Suppose this group is R. Okay, and so we can write it like this, R2BH. Okay, now this R2BH is being added to this alkyne. Okay, so we are getting ETC double bond. ET means ethyl group. Okay, now this R2PH group will be added on either of the side. Both the sides are same. Okay, you can add it either here or on the opposite side. This does not matter. Okay, hydrogen will be added here, right? Now see here, this is treated with CH3COOH. We can write it like this, CH3CO minus H plus. Okay, now what will happen? This boron has a vacant p orbital. Okay, this has a vacant p orbital. It means it is a electron deficient compound. It can take the electron density from CH3COO group. Okay, so that we are getting a product like this. Here is hydrogen. This will remain as it is. See here a new bond is formed. This is R, this R. This boron will accept the electron density from CH3COO and it will form a bond like OCOCH3. Okay, now this will be negatively charged. Okay, so this is now treated with H plus and we are getting ETCH. This bond will dissociate. Okay, this bond will move like this. Okay, and we are getting here ETH. Okay, now see the next example. Suppose we are taking C4H9 C triple bond C H and it is firstly treated with C6H11 whole twice BH and secondly it is treated with I2 and NaOH. Okay, so what is the product? You will have to find out. All right, see here what you have to do. This firstly it is treated with C6H11 whole twice BH. Okay, this is our compound alkyne. This is firstly treated with C6H11 whole twice BH. We can write it like R2BH for our convenience. We are treating it with R2BH. Okay, R is C6H11. So what we are getting? C4H9 C double bond C. Here is H, here is B, R, R. Okay, this will go on the less hindered side. This is moving to less hindered side and this hydrogen is moving at this side. Now this compound is treated with I2. I2 we can write like this. Okay, so what will happen? See here, this double bond has pi density. Okay, this pi density will move on this side. Okay, this will attack on this iodine and this bond will move like this. Okay, so that here will be a positive charge and here will be a negative charge. Okay, so C4H9 and C, this is hydrogen. Okay, we can write like this. This C hydrogen Br2. Okay, and here this iodine is moving like iodinium ion. Okay, now there is I minus. Okay, I minus is remaining. This I minus has electron density and this electron density can attack on the vacant pi orbital of boron. Okay, so that a new bond will be formed. Okay, so this is hydrogen C H. Now here a new bond is formed. This is R, this is R and this is I. When a new bond is formed, see here on this boron now there are 4 bonds. So this will have a negative charge. And here This is iodine and there is a positive charge. Okay, now you can see this is a 3-membered ring. Okay, so there will be a strain on it. So what will happen? See here, this R group will move on this carbon and this bond will move like this. Okay, so that this ring will open. Alright, so we are getting C I C4H9. This is hydrogen. C. This is hydrogen. This is B. And now I am writing here C6H11. This R group is C6H11. Okay. And this is iodine and the next C6H11 group is here. Okay. Now what you have to do, see here. This is sterically hindered. Okay. There is steric hindrance. Okay. So what will happen? There will be anti-elimination. This I is our leaving group and this will always leave out. Okay. And we want a group anti to it and this should be a boron. Okay. So what we have to do? We have to put this boron on the anti side. What we can do? We will move the bond like this. Okay. We can rotate it like this. Okay. So how we can write it? I C4H9. Okay, this is hydrogen and here on this side this is B C6H11 I. Okay, this C6H11 will move here and this hydrogen will move here. Okay, so now what you have to do? This bond will move here and this bond will move here. Okay, this is called anti-elimination. We can write C4H9 C double bond C C6H11 hydrogen and hydrogen. Okay, so this is the product that we are getting. Okay, now see the next example. The next compound is CS3 C triple bond C CS3. Okay, now this is the same manner reaction. You can do it yourself. Okay, so first of all pause the video and try to do it yourself. If you are not getting the answer, then you can see the video again. Okay, so firstly you have to treat it with C2H5 whole twice BH. Then secondly treat it with I2 and NaOMe at minus 78 degrees centigrade. So what you are getting? Okay, see here, CS3 C triple bond C CS3. Okay, firstly it is treated with C2H5 whole twice BH. Okay, so what you are getting? CS3 C double bond C CS3, where you will add BC2H5 whole twice. See here, both the sides are same, so you can add it anywhere. Okay, so we are adding it here, BC2H5 whole twice, and this is hydrogen. Now the secondly, this is treated with I2. I2 means II. So same reaction you have to do. This is the pi bond. This pi bond will attack here. Okay. And this bond will move like this. Okay. So that what you are getting, again a 3-membered ring is formed. Suppose this is below the plane and this is above the plane. Okay. And this is below the plane and this is above the plane. Okay, and this is the 3-membered ring with positive charge. Okay, now in the next step what will happen? This I minus, okay, this will attack with its electron density on the vacant orbital of boron. Okay, so that a new bond will be formed. Alright, so what you have to do? You have to make a new bond between this boron and this iodine like this. And this is C2H5, this is C2H5. Alright, and this is CH3. Okay, this is same. All the other things will remain as it is. Okay, this is like this. Okay, now what you have to do here is the negative charge. Okay, so there will be a strain. Okay, here is a strain. So what will happen? This group, this alkyl group will move here. Okay, and this bond will move like this. Okay, so this bond will rupture. Okay, so this three-membered ring will open. So we are getting C, I, CH3, H, C, CH3. Okay, this is B, C2H5, I, and this is C2H5. Okay, now in the next step you have to treat it with NaOMe. Okay, now what will happen? You know this is plus and this is minus. OMe is negatively charged, it has electron density, so it will again attack on this vacant orbital of boron. Okay, again a new bond is formed. So CS3, I, H, here a new bond is formed. B, C2H5, I, O, Me. Okay, now what you have to do? This is negatively charged. What you have to do? See here, this is highly sterically hindered compound. Now you have to do anti-elimination. You can do anti-elimination because there is a leaving group. Okay, so you want a anti group of this I. Okay, so this boron should be on this side. This boron should be here. Okay, so we can move this bond like this. Okay, so what you are getting? This is I. This is CS3. Okay, this is hydrogen. And here, this C2H5 is moving here, right? Here, you are getting B, C2H5, I, OMe. And here, you are getting CS3. Now you can do anti-elimination. Okay, this bond will move here and this will move here. Okay, so that you are getting CS3, H, C, double bond, C. Here is ethyl group and here is CS3 group. Okay, so this product you are getting. Okay, now see the next example. All these examples are given in the Carothers. Okay, so you can also try yourself. This is firstly treated with catechol boron and then it is treated with H2O. Okay, then you are getting a compound 1. Okay, then it is treated with NaOH firstly and secondly with I2. Okay, then what the product you are getting? Okay, so C6H13, C triple bond C H. It is firstly treated with this boron. Okay, any type of boron you have been given. Okay, just you have to remember that this is the group, that is the alkyl group that is added to this boron. Okay, now you can see here C6H13 is present and this is hydrogen. This is sterically hindered side. So this group will attack on this side. Okay, so we are adding boron on this side. Okay, always remember that boron will attack on the less hindered side. Okay, and hydrogen will attack on the more hindered side. So you have to attach hydrogen here. Just simple. Now you have to treat it with the H2O. Oxygen has the lone pair of electrons. Okay. So this will attack where it will attack. This will attack on the less electron density side. Okay. So here is the vacant orbital. So this will attack on this side. Okay. So you are getting C6H13, C double bond C, H, H. This is boron. Okay. And here this water molecule is being added. Okay. This will remain as it is. All other things will remain as it is. Now what will happen? This is happening. This is having positive charge and this is having negative charge. Okay. And whenever you have given the negative charge, one bond will break up. Okay. So this bond will break up because there is oxygen present here. Okay. So this bond will move like this. So you are getting C6H13, C double bond C, H, H. Here this is boron, this is OH, okay, and this is O, and this is OH. Now again it will treat with H2O. Why? Because there is water present and there is electron density. This is vacant orbital and there is electron density. So it will again attack. Okay. So the same reaction will again happen. Okay. You can do yourself. In the next step or in the ultimate step, you will get C6H13, C double bond C, H, H, and here you will get BOH whole twice. Now, in the next step, you have to treat it with NaOH. NaOH means there is OH minus ion. Okay. And this OH minus ion will again attack on this boron. Okay. So, you are getting C6H13, C, C double bond C, H, H, and here BOH, OH, and OH. So there will be a negative charge. Okay, because boron has 4 bonds. Okay, now this bond will break up. You are getting C6H13, C double bond C, H, H, and here this is breaking in the presence of I. Okay, so this bond is moving like this. This is attacking here. Okay, so you are getting here I. Okay, so you are getting this type of product. Now this reaction can also happen with bromine. When you have given bromine instead of iodine, then you will get an opposite product. Okay, so see here what the reaction. Suppose you have given the same compound C6H13, C triple bond C H. Okay, and here you have given catechol boron. Then it is treated with H2O. Okay, so you are getting the same product. I am writing here the product because we have made this product in the previous reaction. Okay, so we can write it as it is. This we are getting. Okay, now it is treated with Br2 firstly and then with NaOMe. Then what product you are getting? So we are starting from here. Okay, see here C6H13 H C double bond C H BOH whole twice. Okay, this is our first compound. Now it is treated with Br2. See here, this double bond will attack on the bromine. Okay, this is the pi electron density. This is attacking here. So this bond is moving like this. It means we are getting a brominium ion. Okay, here you are getting a brominium ion. Okay, suppose this hydrogen is below the plane and this is above the plane. Okay. Similarly, this is below the plane and this is above the plane. Okay. Now, in the next step, this is negatively charged. Okay. So, this will attack from the anti side. It means opposite side. Okay. This will move here and this bond will move here. So, we are getting C6S13 Br. This is hydrogen. C hydrogen. This is BOH whole twice and this is Br. Okay. Now, in the next step, you have to treat it with NaOMe. This is positively charged. This is negatively charged. This we have seen. Okay. This negative charge will attack where? This will attack on the vacant side here. This is the vacant pi orbital. So it will attack here. Okay. So that a new bond is formed. Okay. So we can write C6S13 Br hydrogen. Okay. And here CH BOH whole twice and OMe and this is Br. Now see here. We have to do now the anti-elimination. Okay. So what you will do, this Br and this group, boron group should be anti to each other. So we will have to rotate the bonds again. Okay. So in this manner you will rotate the bonds. So you are getting CBr C6S13 hydrogen. See here. This bromine will go upward side. Okay. And this hydrogen will move here. And this is B, OH, OH and OMe. This is negatively charged. Okay. This is negatively charged. So now this bond will move here and this bond will move here. Okay. So we are getting C6S13. This is hydrogen. Okay. There will be a double bond and this is bromine and this is hydrogen. Now you can see in this case you are getting a Z isomer. In the previous case when you have taken iodine you are getting E isomer and now you are getting Z isomer. Okay. So in this way you can see that when we are taking the different reagents we are getting different type of stereo products. Okay. So in this way you can make the products yourself, just you will have to take the right stereo. Okay. So practice yourself. If you are getting any problem you can comment me, and if you are liking my videos please share these videos with other students and please comment me. Thank you.